So far, we've talked in detail about the basics of using the Linux command line. Now we're going to talk about how the system starts up and subsequently how the system shuts down. Understanding how the system starts and stops will really give you a lot of insight into how Linux works. So we'll start from the very beginning, which is around reading the bootloader. The bootloader is a small piece of software, usually at the very beginning of a large format like a disk or a large format external storage device that contains only enough code to launch the operating system. Typically, the bootloader is located on the master boot record or the GUID partition table. Importantly, there's a transition happening in computing right now from the old way of doing it, which was the master boot record, to the new way of doing it, which is the GUID partition table. In either case, the concept is the same. Load the operating system into memory so that it can start executing. So to start with, the firmware, which is the embedded software that's on the chip in your computer, commonly called the BIOS or the UEFI for GUID partition tables, provides a list of boot devices to the system. So you could boot from a DVD, from a USB thumb drive, from your hard disk, which is the most common, or even over the network via a protocol called PXE. Once the device is chosen, the BIOS reads the bootloader from the very beginning of that device, and how do you define the beginning depends on whether it's the master boot record or the GUID partition table. The first thing that happens once the bootloader is up is that it opens and initializes the kernel. The kernel image as it sits on disk is compressed, so the bootloader needs to decompress the kernel image. It detects all sorts of memory in the system, how much RAM is available basically, and then creates the kernel's internal data structures. All of that kernel memory, where the kernel's data structures reside, is not available and is protected by the kernel to user space applications. That is an important thing to distinguish. Kernel memory is separate from user memory, and this is for security purposes. The next task that the kernel performs is to detect and configure the devices in the system. It starts by probing devices to look at all of the inventory attached. So this might be the number of processors available, the buses that are available in the system, such as the PCI bus, any I/O subsystems, which stands for input-output, anything coming to or leaving the processor, such as network interfaces, and other storage devices. Then the initial RAM disk is decompressed and mounted. Some essential drivers are loaded that the kernel needs to proceed. RAID drivers to ensure that if there are multiple disks and the file systems are spread among multiple disks for redundancy or performance purposes, RAID drivers make sense of that. LVM stands for Logical Volume Management. This is a technology that enables disks to shrink and grow. Any encrypted file systems, basically the bare bones that is needed for the kernel to mount and continue the boot process happens at this phase. Next, the kernel creates some important processes that it uses internally. Things like you'll see in the process list kjournald, kswapd, and khubd. All of these processes start with a K. Next, the init daemon, and most recently upstart as a replacement for the init daemon, is the parent of all processes. It's spawned by the kernel with the process identifier 1. From there, the upstart init daemon can start up all the other processes on the system. It emits an event called startup, which then begins the system startup process. Next, the local file systems, virtual file systems, and swap, which contains an overload area in case the RAM is full. Those file systems are all mounted, and the services can begin to start up. So the init process, which is started by the kernel and is managed by the upstart system, runs a variety of jobs and scripts to load different system services. So these are things like power management. If you're using a laptop and you close the lid, the computer goes to sleep, the kernel has to manage that. Also the hardware clock. Of course, you know that each Linux system, every system really, has a clock that ticks by, and this is used for all sorts of purposes beyond just looking at the time. The kernel starts up the hardware clock and manages it. It starts and attaches network interfaces and any other network daemons that might be running, such as the SSH server or a DNS server or any other services running on the box. Traditionally, in Linux, the startup process has been handled by something called the System 5 init. This is for historical reasons. System 5 was an old type of Unix, and Linux, having been evolved from Unix, inherited System 5 by default. But System 5 has a number of limitations and is no longer very well suited for today's modern computing world. It's starting to be replaced by a much more flexible, powerful, yet still simple daemon called Upstart. The historical System 5 style init scripts are in the directory /etc/init.d, or sometimes, such as in the case of Red Hat systems, in etc/rc.d/init.d, while Upstart maintains its jobs in the directory etc/init. For each run level, and we'll talk about run levels in just a moment, there is links to the etc/init.d directory in rc.d. So we're going to dive in and see all of this in detail. Don't get too hung up on memorizing all of these directories now. Run levels are really just a numbering system to classify what boot state we're in. And we can just see really quickly what that means by looking at the run levels themselves. 0 represents that the system is shut down and is just not operational. Run level 1, or sometimes referred to as S, represents single user mode, meaning that no network services are started, no other users are able to log into the system. Levels 2 through 5 are a bit redundant and are mainly just multi-user modes used for networking. Some systems distinguish between run levels 2 or 3 and run level 5 by indicating that level 5 is for window managers, like running GNOME or KDE, and run level 2 and 3 is just a command line with no window manager running. Level 6 can be used to reboot the system. The run levels are a bit of an antiquated technology at this point and are mainly still implemented just for compatibility purposes while the system transitions to a pure upstart and start event-based system.